This is Professor Rogers. I wanted to do a video and invite you to walk alongside me again in IntelliJ as we go over some loops, different structures of loops, as well as arrays. I have Zybooks open here as kind of a template. I'm going to be briefly talking about each of these types of mechanisms for loops and for arrays. So what I want you to do in following along with me is open up IntelliJ to this screen. We're going to create a new project and just make sure Java is selected at the top. Click Next. Leave these unchecked for right now. Click Next, and we'll just call this Chapter 4 and 5 Examples. Or whatever name you decide is fine, just something unique. All right, so we're going to click Finish on that, and I'm going to open up my project, go to the source directory, right-click on it, and click New Java Class. Now, since we're going to be talking about loops, I'm going to do a class here to demonstrate different types of loops. So we're just going to call this Loop Examples. Okay. In IntelliJ, as I've mentioned before, you can type PSVM and then tab, and that will give you your public static void main method. Now let's look at some of the loops and their concepts in general. In Java, we have several kinds of loops that you can use. You can use a while loop, you can use a do while loop, and you can use a for loop. And with for loops, there's also a variation of the for loop called a modified for loop. So let's start with a basic while loop and talk about the general logic behind it. In a while loop, you're going to start with the keyword while and then use your code block, which is the curly braces. And for the while loop, you're going to use a parenthesis, and in the parenthesis, the value inside the parenthesis has to resolve to true. Okay? It has to resolve to a Boolean. So in this instance, I'm going to create a new variable, and I'm going to demonstrate how we could possibly use a while loop to count to a certain number. I'm going to use 0 as my instance. Let's see, int count equals 0, and I'm going to make my while parenthesis, the Boolean logic inside here. I'm going to say while count is less than 10. So let's talk about how we would do a simple loop with while count is less than 10. I'm going to use SOUT. I don't know if you caught that or not. In IntelliJ, there's some keywords you can use. If you type SOUT and then tab, you get the system out print line. If you use SOTUM, you get print's current class method, SOUTP, and so forth. Little keywords to make things easier. Okay, so system out print line, and I'm going to take my count variable, and I'm going to basically prepend it with a string literal and say this: the count is, I'm going to use my plus operator for addition, and using an addition operator with a string, it concatenates the value, the numeric value, to the string literal. So just going to put count, and then below this I'm going to say count plus plus. And if you remember, when we say the double plus symbol, this is a this will basically take the value of count and it adds 1 to it. And that's basically the shortcut for that. It's also the same as doing count plus, let's see, plus equals 1. It's identical. Okay? All right, so I'm just using the count plus plus. And so we have the count is, And that's basically what I'm going to do here. So I'm going to run the code, click Run the Loop Example. And this will basically demonstrate that we have printed out roughly 10 system out print lines, iterating from the number 0 through 9, right? So there's a count of 10. So while count is less than 10, which means once it reaches 9, it will stop. Okay? All right, so that's using the while loop. Now, the important part of the while loop is that the logic that starts it is here with the Boolean condition. And with a while loop, it will run at least one iteration before it checks the value. It will check the value before it runs the iteration. Now, there are scenarios where we want to run at least one iteration before we check the value. And we would do that by using a do while loop. And again, same methodology, but we'll put the value of true down below. And with a do while loop, if I use a system out print line and put in a string literal running the do while loop at least one time. And to ensure that it runs just only one time, I'm going to change this to false. Because remember, as long as the logic checking facility here in the while loop is true, it will continue to run. Okay, so we'll run it again. We'll click the little run symbol that was here, and you'll see that it will print out that it ran at least one time. Okay, so it ran one time. So what do we want to do if we want it to run multiple times? Well, you would change this logic to be something other than something that would resolve to a Boolean condition of true. So while the condition is true, it will run. It's the same thing for the while loop up here. The difference is that the condition could be false and the code inside the code block would not run. Whereas in this one, in the do while loop, inside the code block, the line of code will always run at least one time until it resolves with the while statement. Okay, so this is not a very good example using false. So let's do another scenario. Let's say while the loop is greater than 10, while the count is, let's say, greater than or equal to 10, and less than 11, or let's say 12. Now you'll notice here that I have to put count again. And in this scenario, let's see, we got some errors here. What is our error? Let's take this out for a moment. What are we missing? Let's see. Count is there. Okay. I am a dweeb. Okay, there you go, guys. Even your professor can make mistakes, right? All right, so while count is greater than or equal to 10 and count is less than 12. All right, so in this instance, it will run through here, and it'll keep running at this point as it gets to system out print line, because I don't ever have a way that makes count less than 12. Now, to point this out, what will happen is we'll get an eternal print of running the do loop at least once, because there is no exit. So to kill this, you'll just use the kill switch here, or if you're running it in terminal window, you use a Control C on your keyboard. Okay, so we have to make sure that the count is less. Otherwise, you end up with a unending loop. Okay, so how would we do that? Well, we can continue down here and just say count plus plus, right? So if we do that, we know that this will print at least one time and then I believe 2 more times. So we'll run it again. And it reached its conclusion. Now, I didn't include the variable in the string literal here, so we'll just include the variable up here. And you'll notice that I'm using some parentheses and some quotes to kind of encapsulate that value. Now, if I run it again, you'll see how how count continued. So it went up to 9, and then inside the parenthesis we have 10, and then 11. All right, so this is using the count methodology. The other way that we can do this is with a for loop. And with the for loop, we would basically, it starts with the keyword for, and we have a parenthesis. And in the parenthesis, we establish 3 characters, and this is with a normal for loop. The first character is going to declare the incrementer. And so in this case, I'm going to use I. We're going to say int I equals 0. I now has been established, but now we need to say what the logic condition is. The logic condition needs to be when I will quit. So we're going to say I is less than 10 and I plus plus, the incrementing. Okay, this is our incrementer. Now, you could also have I be declared here, int I equals 0, and just simply use this kind of logic. I typically and often declare my variable inside the for loop. All right, there are some use cases where it might be necessary to declare it out here. All right, so in this instance, we've established the creation of the variable I equals 0. We've expressed that I, in this logic instance, that the for loop will run as long as I is less than 10, and how I will increment. Essentially, it's the same as a while loop. We've declared the variable up here, we've set the logic condition, and we've set an incrementer. But in a for loop, it requires all 3 to be present in the parenthesis. All right, so let's set up our statement again. We're going to say that I am inside a regular for loop, and I equals, remember we have to use the plus, I. Okay, now if we run this again, we'll see that we have our while loop, we have our do while loop, and then we have the statement from the for loop. Now these are common ways that you can set the logic to run a loop. The other way that you can actually exit or jump out of a loop is you can use what's called a break. Right? So let's go back to a while, and we're going to say while true, have a code block, and inside here I'm declaring a variable, and you'll notice that I can declare I here inside this code block and it doesn't complain. However, if I declare I up here, it will complain. And the reason is that inside the code block, the scope of the variable has changed. Okay? All right, so int I equals 0 and I plus plus, and if I is greater than 10, I'm using a curly bracket here because this is always a good idea to wrap your code, especially as your logic may grow. You'll always know if you're wrapping it that what's inside your logic block here. I know in branching that you don't necessarily have to have the curly brackets, but this is always good advice to follow. In my 13 years of programming as a Java developer, you don't know how many countless mistakes have been made by forgetting that you don't have a curly bracket to wrap your code, and then you add an extra statement in here. And if you don't have the curly brackets, you think that the second one will run. It won't. Okay, so curly brackets will save your lives. They're like commas. All right, anyways. So if I is greater than 10, system out print line. Let me take this out. I am going to exit now because I am 10. Now, how am I going to exit? All I've done is just put a system out print line. Well, the way you would do this, you would cause the while loop to stop is with a break. And break will exit the code block, the loop condition there. So if we run it again, we'll see that while true is equal, it's going to continue to do this until it reaches that condition. Okay, that was fun. I had to pause there awkwardly because the power went out and I lost everything on my screen. I want to point out something with the code that we just ran, and this is a good spot to talk about variables and variable scope. Because the variable scope for I is 0, each iteration that it comes through, guess what it does? It resets I back to 0. So in this instance, int I equals 0, plus plus, it's now 1. It never reaches 10. It comes back up. I is now 0, and it keeps going. So in order for the break to actually work, we're going to have to move I up to here. And now if we move I to this level, the scope of the variable is outside of the code block. And inside the code block, when I++ iterates, it will move I up one level, but it will not reset it back to 0 because int I equals 0 is outside the code block. So let me demonstrate to show you that using the break will actually cause the code to run as we were expecting it. And as you can see, I'm going to exit now because I equals 10. All right, so this is another way that you can exit from a while loop. You can use the break syntax to exit from any for condition or do while loop or whatever. And sometimes the break condition becomes important. So say you have 10 elements and you're searching across those 10 elements to find a value. And if you find it within the first 2 elements, it may make sense to go ahead and exit the loop. Because why go ahead and run the extra logic upon each of those extra elements? This becomes increasingly important as you think about iterations of 1,000 or 10,000 or 100,000. You want to exit the loop as soon as you can. So you want to make sure that you can reach a true condition as soon as you, a condition that allows you to break from the loop as soon as you can. And that's the power of using a break. Now, we've talked about loops and for loops and while loops, but you can nest a loop inside of a loop. So for example, I could have inside of this if condition here, I could have another for loop. And I could say int j equals 0, j is less than 3, j++. And I could ensure that before I break out of this while loop that I'm actually using another for loop. And so I could simply just put, just so we're printing what j is. And if we run that, the condition will state I'm about to exit now because I'm 10, and then it'll say j 1, 2, 3 or 0, 1, 2, and then it'll break and exit the loop. You can also incorporate those types of looping mechanisms where you could have a for loop inside of a for loop. For example, we could say a for loop int k equals 0, k is less than 3, k plus plus. And what would happen here is this system out print line will print 3 times for every 1 time it's called. So from this instance, I could say k plus j, and k plus j will actually do a mathematical operation. Okay, so if we run that, you're going to see a little bit different scenario. Now we see 0, 1, 2, 1, 2, 3, 2, 3, 4, because it's running the extra for loop inside the for loop and it's doing the addition. So those are loops inside of loops, and you could technically nest a loop inside of a loop inside of a loop, but keep in mind that the iteration for that loop is tied to the above loop. So this loop k is tied to each iteration of the incrementer at this loop with j, and j is tied with each iteration of the loop that occurs at the condition for while y is true. Now, in this instance, we're not running the for loop until I is less than 10, or I is greater than 10. But realistically, you can take that out and do this, and for each iteration of the while loop, where I is 0, it will run the j, and then I is... And so you can see that it continues to build up. You can nest upon nest upon nest. It's so forth. Okay, there's other ways that you can use the keywords, like, for example, the keyword continue. And in your zyBooks, chapter 4, when we talk about the continue, let's see if we can bring it up here. In the example, they're using the break. And let's see, where are we looking for? There's the continue statement. And according to zyBooks, a continue statement in a loop causes an immediate jump to the loop condition check. So a continue statement can sometimes improve readability of the loop. All right, let's take a look at the example. So here we have a nested loop. So if this condition is true, we're going to continue. Okay, and it's going to evaluate the condition of the loop, meaning it's going to skip the code and come back up here. Now, that sometimes can save logic for the different types of things that you're doing. All right, let me jump back up here. And we've talked about variables and scopes. The last piece that's in here in your zyBooks chapter is on enumerations. Enumerations are another type within Java. You can create your own public classes, which are enumerated classes as well. So let's go ahead and take out some of the code here inside of our class. I'll go all the way up to the public void main. Pull the code out, and let's talk real briefly here about enumerations. I'm going to read to you from 4.1 out of enumerations in your zyBooks textbook, and it says some variables only need to store a small set of values. For example, a value representing a traffic light need only store values named green, yellow, or red. An enumeration type declares a name for a new type and possible values for that type. Okay. An enumeration can be a class, and so you could have public enum type, right? You can also, and you can typically declare these inside of a class, and so we're going to declare this here at line 3, and I'm going to declare one called public enum bank types. I'm going to use the curly brackets, and inside of that, I'm going to say in caps. This is usually the methodology you want to use because enumerations are kind of like constants. Okay, so I'm going to say checking savings IRA, and comma. Now let's talk about a few things about the enumeration. We have the public access modifier that's making it public to those inside the class and folks outside of the class. We have the enum type itself that declares the type of value this is, and then the variable. So my variable is bank types. You'll notice though that this does not include an equal symbol, and that's because when we're declaring an enum, it's almost like a class. You're declaring a class in a sense, and the values in that class, checking, savings, and IRA, are sort of like arrays. However, you don't have to specify a length for those, and we're going to get into those arrays in a little bit in our demonstration. So I have checking, savings, and IRA. And in my code block here, I'm going to remove a line, and I'm just going to say system out. Whoops. Let me back that out. Use lowercase when you type this. Sout. System out print line bank types. And then I'm going to call the value that I want to see, checking. Now, system out print line bank types will print a string of that value of that bank type. So if we run that, that will give us a checking object. Now, as well, we can actually iterate through our bank types. And we didn't cover yet the modified for loop. We're going to get into the modified for loop probably more with arrays in the next chapter, because that's where we see the power of it. But let's go ahead and use our modified for loop. A modified for loop is the same as before. Inside of our for loop, though, we're going to reference the enum. And so I'm going to call my variable bank types, because it's like a class in a sense. And I'm going to say bank types to create a new variable from my bank types, and I'm just going to call it type colon, and then bank types. Now, bank types, I really need it to give me back an array of those values, and that's what the values method here will give me, is an array of bank types. Now, if I want to iterate across them, I can just use type, and for each call of the modified for loop, it will print out the type. Okay, so I'm just going to run this again so you can see how the power of the enum. Now we have checking here, but that checking is from this system out print line. So let me let me do this a couple of times so we have something to separate this. Okay, this is just for visually so we see it separated. When we run this again, you're going to see that it iterates through the bank types with a checking, a savings, and an IRA. So here we have it, checking, savings, and IRA. And likewise, we could add other enum values to this. We could have checking, saving, IRA. I don't know. Let's see. What's another bank type? How about a loan? So you could add a loan to this. And that will as well iterate out with our enumeration type. All right, so we've looked at loops, for loops, while loops, modified for loops. We've looked at the scope of variables within the code block. Remember, the code block is always these curly brackets. We've looked at enums and ways that you can use enums. So let's go back over to Zybooks here. And that pretty much covers those topics on loops. And then you have several things you can do there. Let's go ahead and look at arrays now. All right, an array. An array is really, it's a mathematical concept. Remember that each variable that you declare takes up a specified location in memory. And you're declaring that location in memory to contain a type. And in Java, the variable type gives us type safety, so that when we pull that piece of data from an area in memory, we know it is a certain type. And when you declare an array, you're basically saying, I want to take up the exact amount of space for these types of data. All right, think about that for a moment. These types of data. An int will take up so much space. A long will take up a little bit more space. A double takes up a different type of space. A float takes up still a different amount and type of space. Characters, strings, all of those take up different amounts of memory. And when we use an array, we're saying grab a collection of places and we're going to store them all with a certain type of data. All right, let's go ahead and take out this information, and I'm going to declare a simple int array, and the syntax for that would be int square brackets the name of the array that you're going to declare. So I'm going to have mine as values equals new int square bracket semicolon. Now at this place you declared array, but this array is of no value because you haven't specified how many memory locations it should take, and so you have to specify. So I'm just going to say 5. So I have an array of type int that's going to take up 5 spaces. This is essentially how you declare an array. Now if I want to use the array has a couple of things that we need to keep in mind in how we address the memory location for its usage. I have my value, and I have to use this subscript notation here. And this is known as the increment value, the subscript notation for the array. And so if I want to address an array, I would always use a number between 0 and its max. All right, this is the part that's going to throw some of you off. So I'm going to type this out in comments here so you can see a little bit better. If I have an int array of value, the first position of this array called value is identified by a subscript of 0. That's the first position. And likewise, I'm saying it's going to be a total of 5. And so my 5th position value in my array for the array value is 4, because I'm counting from 0 start space up to the last number. So the value is, I have an array called value and it's 5. And actually this should be called values because arrays are typically plural, right? That's the correct notation. All right, so now if I want to address a particular location in that array, I would address it between 0 and the max. So the max will always be 1 less than the number identified here. So if I've identified it as 100, the max value would be 99. If I identify an array of 50, the max value would be 49. The subscript value would be 49. All right, so in this instance, I have an array of 5 values, and I'm going to start with position 0. And the way you populate an array is very similar how you would assign values to an int. If I had a regular int value that was an array, I would do pretty much the same thing. I would say value equals my number. And because it's an array of ints, I can only assign it int values. Okay? All right, so let's populate our array then. So I'm going to populate value 1 equals, let's make it a different number, 56. Subscript of 2, which is position 3, I'm going to give it a value of 98. Subscript position 3, which is position 4 of the array, I'm going to give it a value of 3. In values subscript position 4, which is the actual 5th position I'm going to give it a value of 2. All right, so I have an array with all these different values in it. And now if I want to see those values, I can call them just like I normally would, and I would call the value that exists at that position. So if I call value of position 3, subscript 3, and I do a system out print line on this method, it will tell me what's at position 3. And position 3 is the number 3. If I change that to position 2, and I run this again, position 2 should generate 98. And as we see here, it generates 98. All right, now what if I want to access all of these in a more clear-cut manner? Well, this is where the power of an array comes in. So if I say int I equals 0 and I is less than 5, think about the logic there. I'm mapping my values to the subscripts. Okay, mapping my value to the subscripts, not the position. The subscript value is 0, 1, 2, 3, 4. Positionally, 0 is 1, so forth, right? All right, so int I equals 0, I is less than 5, and I plus plus. And then I do values, I give it I, right? All right, so let's put this in a system out print line. And we're going to prepend this with a string literal, and we're just going to give it something that makes sense to us as we read it. So we'll say position, now you all bear with me here, I'm going to wrap this in a parenthesis because I'm going to do some addition on it, and I don't want it doing something else. So I plus 1. Now if I used I plus equals 1, I'm going to change the value before it gets over here. You don't want to do that. So the position I is, all right, let's look at that, make sure it makes sense. Here's my string literal. Position 1 is this value. When it increments, position 2 is this value. I'm using the 1 because remember my value of the array is at 0. Okay, so I want you to see it from the perspective of something that makes sense. All right, so as we run this code, we're going to see that position 1 is 1, position 2 is 56, position 3 is 98, position 4 is 3, position 5 is 2. All right, let's add something else here. Plus at subscript I. My subscript is this value inside the bracket. Okay, so to make it readable, I'm just doing this, putting this in quotes so that it looks like something you're expecting over here. All right, so we'll run that again so you can see how we're iterating through that array. So my position 1 is 1 at subscript 0. All right. Now the other thing about arrays, arrays also give you this cool little feature. So you can say values.length. And values.length is actually going to specify the number of possible elements. And the number of possible elements is going to be that number right there, the 5. Now to show you, say system out print line, the length of the int array values is length, and we'll print that out. So the length of the int array values is 5. We do all this code. So therefore, the other thing you can do, if you're given an array and you don't know the length, and this is very common, the one way you could specify what this value is here for your for loop is to simply just say values.length. And values.length will give you that max element. And if you run that again, you'll see that it still runs exactly the same code. Right. Now, here's the catch. Let's say that you make the mistake and you say something like this. Values subscript 5 will equal 56. This will not complain when you compile it. It'll compile fine. But at runtime, you're going to get an error. Let me demonstrate. Java, remember, is type safe, and it protects you with exceptions. Now, if you're using C++, you could do this, and you could overwrite a piece of memory in your on your computer. It will actually affect another piece of memory on your computer, and some application will stop working because of incorrectly doing this. Especially if you're using up a lot of RAM. This is also how what we call white hat hackers, they test code and they do things where they call index arrays out of bounds to see if it will cause the program to break or allow you to hack a system. This is a very popular way. Java protects you from this. So when I run this, it will produce a compile time error, and you'll see a nasty exception. And the error it gives you is array index out of bounds. 5, index 5, this value here, is out of bounds for the length of 5. Because remember, the length is 5, but that means that the index only goes to 4. And that's the way your arrays, they typically work. All right, so this is, in general, how you could do an array. Now, you can also do arrays. We did this with an int. You can also do arrays with a char. And heads up, a char array is what powers a string. So I could specify a 4-letter character here, and I could say char 0 equals let's say C char equals A I'm not thinking, folks. You actually got to do it like this. Remember to use your variable. All right. So my word char2. Losing track of where my cursor is. Char2. And then my word 3. And so we use the character array to contain our characters. The other way that you can actually populate arrays, and this goes for ints, strings, characters, even custom objects, is you can use the code block statement. So for example, let's use a string, and I have a string array of my words, and I say equals code block And the way this works is that the code block has to be comma delimited. So characters are single quotes, strings are double quotes. Always remember that. Hi, everyone. It's right. And you'll notice that here I even include a comma and that this is totally legal with arrays. Now, by doing it this way, it's implicit that the length of the array is 3. Okay, you can create your char arrays the same way, your int arrays, as long as they're comma delimited. Always end with a semicolon after that. These are the two ways that you can create arrays. Now, you can also store types. For example, I have a class up here called loop examples, and I could create a loop examples char, and I will say, we'll just call this LE equals new loop examples, and I'll specify the type 2, and then if I look at LE and I say LE subscript 0 equals new loop examples. And so I'm assigning a new value to my array using that process. All right, so these are some of the things you can do with arrays.